Welcome to this video. In this video, we will be talking about the Spearman rank difference coefficient of correlations. Here are the key ideas. The Spearman rank difference is applicable when the set of scores that is available is in terms of rank order and when the set of scores is small. It is also known as Spearman law. The formula for the Spearman law is 1 minus 6 summation of d squared over n multiplied by n squared minus 1. Here are the things to remember. When n is 10 or greater, testing the significance of ρ can also be computed using t-value. The formula here is the formula for the t-value, which is ρ multiplied by the square root of n minus 2 over 1 minus ρ squared. The formula for the degrees of freedom in this method is n minus 2. Now I will be showing you an example on how to solve Spearman rank difference. For this sample question, I will be showing you a total of 7 easy steps. Step 1. Make a chart. Use the given data and add 2 more columns, d and d squared. Step 2. Subtract the pairs of column X from column Y and write the difference on column D. Step 3. Square the pairs of column D and write the products on D squared. Step 4. Add all the rows, which will be your n, and add the numbers on column D squared. Write the results at the bottom of the column. Step 5. Now solve using the formula for ρ. Using the formula, you will be substituting it in their appropriate places, and that's how you get the answer. Step 6. Find the degrees of freedom using its formula, and also find the tabular value, which you'll be referring to the table. In order to find the tabular value of Spearman rank difference in this example, scan the given QR code. And for the last and final step, compare the CV and the TV, then decide. Note, let your raw be the computed value, or CV. If the computed value is lesser than the tabular value, the hypothesis will be accepted, and if the computed value is greater than the tabular value, then the hypothesis will be rejected. And here are the summary of answers. From the past example, the pairs were already ranked. Now this next example would require you to rank the numbers of column X and Y before you start subtracting. In this example, we have to rank the numbers in column X and Y before we start subtracting. So we have here in our table the different columns, which is the instructor, third year, fourth year, D1, D2, D, and D squared. Our X will be the third year and our Y will be the fourth year. Under the column of D1, we will be ranking the numbers in column X, which is the third year, and under the column of D2, we will be ranking the numbers in column Y, which is the fourth year. In ranking the numbers, we will start by the highest going to its lowest. And here we have our rankings. As you can see here in the fourth year column, there are two numbers which are the same, the two 46 numbers, and you may ask how to rank them. You just simply add both their ranks, like we all know that 46 here is ranked as third, so it means that the other 46 is ranked fourth. Add 3 and 4 and divide its sum to 2 to get the ranks, and that's how you get 3.5. Rank the numbers being 1 as the highest and 10 as the lowest. Now, after ranking, we can now subtract the numbers under column D1 and D2. After subtracting, now we'll be squaring the differences. After squaring, write the answer under column D squared. Then, we can now start solving for the raw since we've finished the table. Again, the formula for raw is 1 minus 6 summation of d squared over n multiplied by n squared minus 1. Then you can substitute it with their appropriate numbers. Since our n here is 10, as what is said in slide number 3, that if n is 10 or greater, testing the significance of raw can also be computed using t-value, which has the formula of raw multiplied by the square root of n minus 2 over 1 minus raw squared. And so we are to compute using the t-value. Then, find the degrees of freedom and the tabular value. Instead, for the raw to be the computed value in this example, let your t be the computed value. Here are the answers and you are done with example number 1. In this next example, the given numbers is now more than 10, so we will be solving this using the t-value. Now, rank all the numbers under the age column and put their corresponding ranks under the D1 column. The same goes for the numbers in the blood pressure column and put their ranks under the D2 column. So here are their answers. Now, after ranking, we'll be subtracting the numbers under columns D1 and D2. After subtracting, we'll be squaring the difference between those two numbers and put the answers in the d squared column. Once you are done with the table, start solving for the raw and the t-value. Again, remember the formula for the raw, which is 1 minus 6 summation of d squared over n multiplied by n squared minus 1. And for the t-value, which is raw multiplied by the square root of n minus 2 over 1 minus raw squared. After solving for the t-value, find the degrees of freedom and the tabular value. Here is a summary of answers. Since the computed value is higher than the tabular value, the null hypothesis is rejected. I hope you enjoyed and learned a lot. Thank you for watching.